Okay, welcome to the module on solving equations. We thought it would be good to include a module or a video up front just talking about some terms and definitions, because sometimes some of these terms themselves cause some confusion. So that's the purpose of this first video, just to kind of set the stage with some terminology. We know we throw around words like evaluate and solve and write an equation for, or what's the solution set, and if we don't define what those things mean, it sometimes can be confusing. Okay, so a lot of mathematics is about solving problems that involve quantities or measurements that can be quantified, right? So here's some various words that just mean quantity. Quantity, number, value. Those things mean a quantity, and we would represent those by numbers in our number system. Things like 2, -42, pi. Those are numbers, so they represent a quantity, and that's the kind of building blocks of most of mathematics. Okay, variables, sometimes we're not sure at first what the value is going to be for a quantity, so we have to represent that with a placeholder of some kind. And so we call that a variable. Variable meaning something that can vary, that can change its value. Right? So it's just a placeholder for a value. It could be used wherever we could use a value, and it doesn't have any particular value. It could take any possible value that's allowed for the type of the number that it's standing in for. So to distinguish it from numbers, we tend to use letters, things like X or Y or B or W, something like that. So that's a variable. Okay, an expression is just a way to express or say or write a value. It's usually a combination of other values or variables and values that are grouped together using operators. And an operator is just a symbol that indicates the way the parts of the expression should be combined. So here's some examples of expressions. They're just expressing a value. Right? 2 plus 4, that expresses a value. X minus 2 expresses a value. We don't know exactly what the value is unless we know what value X is supposed to be, but it expresses a value. This most complicated expression here, 2x cubed minus 4x squared plus 3x minus 15, it still represents a value if I know what X is to put in there, right? And X minus 2 over 3x represents a value. Okay, so what does the word evaluate mean? Since that contains the word value, evaluate means to find the value of something. So if we have an expression that involves no variables, like 2 plus 4, evaluate means to write what the simplest way is to express the value. 2 plus 4 can be expressed as a 6, so that's the value of that. So to evaluate the expression 2 plus 4, we would just add the two numbers. Or maybe we have this 2 times 15 over 3, so maybe we multiply the 2 and the 15 first, and then we do the division. And so evaluate that would mean to evaluate that to a number. If we have expressions that contain variables, then we really we have to know what the values of the variables are before we can evaluate. Right? I can't express 2x minus 10 as a value unless I know what x should be. But if they tell me that x should be 4, then I can plug 4 in for the placeholder x, and then I can evaluate this expression and come up with the value of that as 2. Even a more complicated expression like this, if I know the values for the variables, I can plug those values in for the variables, right? 2 for W and -3 for C. Everywhere there's a 2, or a W gets replaced with a 2, and so on. And so what would I have? I'd have 4 minus 9 over 2 plus 3, because negative there cancel. And that would give me -5 over 5, and so this expression evaluates to -1 if I know what to put in for the values for the variables. Okay, so that's what evaluate means. What about equation? This word equation. Well, an equation is a mathematical statement. It just says that one expression is equal to another expression. So equations always contain equal signs. They always contain an equal sign. So I know all 4 of these examples are equations because they have an equal sign. And an equation can be very simple, like 4 equals 4. Right? Y equals -12, or it can be extremely complicated. X squared over 3 plus 12y cubed equals -14x plus 3c. But what makes it an equation is the fact that we have one expression on the left equaling an expression on the right. And there's an equal sign. So what is the solution to an equation? Now we're getting to something a little bit more important here. For equations which include at least one variable, then the solution to the equation is just the list of all the values of each variable in the equation that will make the equation true. Okay, much of algebra, especially Algebra 1 2, is learning procedures that allow us to discover those solutions to the equation. So you could have some really simple expression or simple equation here, y equals negative 12, and that means that the solution is going to be any value of y in the left that will make the left side equal to the right side, and so the only value would be y is negative 12, right? Kind of a trivial solution there. But we could have more complicated expressions. So let's say I have this equation 4b minus 7 is 13, and I want to see whether or not the value 3 for b is a solution. Now if it is a solution, if I put 3 in for the b, it should make the equation true. So let me just do that. I'm going to write the equation over again, and when I get to that b, I'll put a 3 in there and see whether this works. So that's going to be 12 minus 7. That's going to be 5 on the left side, so the left side evaluated to a 5 and the right side evaluated to a 13. That's not true, and so that we would say no, 3 is not a solution to this equation. Okay, what about 5 here? We got 4 times 5 if I plug 5 in for b. That's 20 minus 7. So the left side evaluates to 13, the right side evaluates to 13. So yes, 5 is a solution to that equation. And you might ask how many solutions this equation has. This particular kind of equation has a single solution because there's only one variable and nothing squared. Okay. How about something more complicated with 2 variables? Well, we're not going to be able to test whether a solution is correct unless it contains both an x and a y, because we can't evaluate the left side to a number unless we know what x and y both should be. So we have to have x's and y's that occur in pairs. So maybe we have this, x is 2 and y is 0. We could write it as a coordinate pair, or we could write it out like this, x equals 2, y is 0. And we're going to plug that in and see whether this is a solution. So we have 3. 2 goes in for x, 0 goes in for y. That would be 6 plus 0 is 6. 6 equals 6. So actually, yes, this point 2, 0 is a solution. In other words, that particular combination of x and y makes the equation true. Okay, let's take a look at another one here. How about 4 and negative 3? Well, let's take the equation. We'll plug in 4 for the x, and we'll plug in negative 3 for the y. So we have 12 minus 6 is 6. 6 equals 6. Wow, this one is also a solution. 4, negative 3. At that point, you might ask yourself, well, maybe every combination of x and y works. I don't know, is that true? Maybe every combination works. Well, let's try this one. X is 3, y is 2. 3 times x plus 2 times y equals 6. That's going to be 9 plus 4. 13 equals 6. Actually, so that one's no. This particular combination didn't work. Alright, so you might ask how many solutions this equation has. And if you know your equations of a line, you'll know that an equation that has an x and a y, nothing squared, is the equation of a line. So actually there's an infinite number of points. For every x that you put in, there's a matching y. We'll talk more about that in other videos. Okay, so what does it mean to solve an equation? Well, it means 2 different things depending on what the equation form is. If the equation has just one variable, then solving the equation means to find all the values that make the equation true. And the way we typically do that is we try to isolate the variable, because then we just have the variable on one side and the number on the other side, and we can tell what that number has to be. So we would do procedures like this. Subtract 8 from both sides, and then divide both sides by 5 to figure out that x is negative 2 appears to be the solution, because I was able to do algebraic operations that kept the sides equal, right? And I ended up with just the variable on the left and a number on the right, so the variable must be equal to that number. We could check that to see if indeed it is a solution by plugging that back in and verifying that the result is true. And in fact, since both the left and right sign do resolve to negative 2 and they're equal, then that means negative 2 is the correct value for x. That's the solution to the equation. What about something like this? What if I had x minus 2, x plus 4, x minus 7, and there were 3 factors multiplied? Well, if I were to plug in, let's see, there's going to be some value for x that makes this left factor 0. That would be x equals 2. Let's try that and see what happens. I would have 2, and if I plug it in everywhere, what do I get here? Well, this left factor becomes a 0, this is a 6, and this is a negative 5. but because 0 times anything is 0, just because that left factor is 0, the entire side is 0, and that means that yes, this one is a solution, right? X equals 2 is a solution. Okay, but that's not the only solution. Let me erase this, and let's look at the second factor. What would be the x that would make that 0? Well, that would be x is negative 4. Let's plug that in everywhere and see. If I plug negative 4 in everywhere, what do I got? I've got negative 6 here. This middle thing becomes a 0, and I have negative 11. But because one of the factors is 0, the whole thing is 0, because 0 times anything forces that whole side to be 0. So x equals negative 4 is a solution. And actually, we can just, without checking it, I think we can see that the solution for the third factor there is 7. So this particular equation has 3 x values that make it true. 2, negative 4, and 7. Okay, you might have something like a quadratic equation, x squared plus 2x minus 8 equals 0. The subject of the next videos is how we can find those same values, either by factoring or other means. So we'll leave that for another video. Okay, one more topic before we summarize. If we have one equation and it has 2 variables, then there's usually not just a single set of values that make that true. There are many pairs of values that make that true, like the line example we saw earlier. But we're still asked sometimes to solve the equation for one of the variables. Okay, now that doesn't mean we're going to come up with a solution set, a set of numbers that will make the equation true, but it means that we're isolating the variable. So if this says solve this equation for y, it means we want to manipulate the equation so that y is by itself on one side. And we would do that by adding 2x to both sides and get that y equals 2x plus 4. So in some sense that's solved. We don't have solution sets, it's not evaluated really, but it is ready to go. We could plug x's in and find matching y's. Okay, let me summarize this. We may run out of time, but see if we can summarize this. So we said that value, number, those all mean quantity. Those words mean quantity. A variable is just a placeholder for a value, and it can hold many different values. Right? An expression is just a group of numbers or variables that can be combined using operators. Right? The word evaluate means to find the value of something. And then an equation consists of contains an equal sign, and it shows that one expression on the left is equal to another expression on the right. A solution to an equation is the set of all the values for the variables which make the equation true. There might be a single value or many values that are the solutions. For an equation with just one variable, solving the equation means to find the solutions, to find the set of the numbers that make the equation true for all the variables. And then for an equation with multiple variables, solving the equation for a variable just means to isolate that variable on one side of the equation. All right, I think this wraps up this introduction to the terminology. There's just a short practice session related to this, mainly related to practicing evaluation, but the real meat of the solving section is in the sections on solving for quadratics.